Hello students, good morning and welcome to another lecture of physics. I am your tutor Meet, and if you remember in last video lecture we have discussed about measurement of length, right? Measurement of very small distances. Say for example, we have seen how we can measure a distance up to 1 mm, right? By using a scale we can measure distance up to 1 mm. Then by using vernier caliper we can measure distance up to 10 raised to -4 meter. In the same way, by using a screw gauge or a spherometer, we can measure length up to 10 to the power -5 meter, right? And if you want to measure distance beyond that, that is something around, let us say 10 raised to -7 meter, then we can use microscope for that, right? So microscope uses visible light which has a wavelength of 10 to the power -7 meter, and hence we can resolve an object up to the size of 10 to the power -7 meter by using such microscope. On the other hand, we do have electron microscope which can measure a size of object as small as 0.6 angstrom, right? And we have also seen in detail the method how to find the diameter of oleic acid, right? How we can find the diameter of oleic acid with a small experiment. We have already discussed this in our last video lecture. Now in this video lecture we are going to discuss an interesting topic about mass. Something we will discuss from textbook, and most of the things will be extra information which will be quite useful for you. Not exam point of view, but it will be quite useful to you, right? You should know such things. So now we are going to discuss about measurement of mass, and next we will discuss about measurement of time. So let's start with measurement of mass. Topic for today is measurement of mass. Now what is mass? I think you have come across mass and weight in standard time. You are aware of the difference between mass and weight, right? What is mass? Mass is a basic property of matter. You can say that mass is a basic property of matter which is independent of external parameters, right? Mass is a basic property of matter and it remains constant. Something like this you have come across, right? While weight depends on the location of the body, right? In space, weight will be something different, right? Maybe 0 or something like that. Because weight depends on gravitational acceleration, right? So as g will change, gravitational acceleration will change, weight of the body will also change. But mass is a basic property of matter which remains constant, right? So you can say that what is mass? So mass is a basic property of matter. Mass is a basic property of matter. You can say that mass is a basic property of matter, and it is independent, or it does not depend on external parameters. It is independent of external parameters such as temperature, pressure, or location of matter in space. If you take this matter anywhere in the space or on the earth or any other planet, its mass will always remain constant. So you can say that mass is a basic property of matter which is independent of pressure, temperature, and location of the matter in space. Now, the prototype of International Standard Kilogram, is supplied by International Bureau of Weight and Measurement. Who is supplying the prototype for mass? It is supplied by International Bureau of Weight and Measurement. They are supplying the prototype for the mass, right? Now, this kind of prototype is available in many countries, right? This type of prototype for mass is available in many countries, and in India this prototype is available at NPL, National Physical Laboratory, which is situated at New Delhi. So the prototype of mass in India prototype of mass in India is available at NPL, that is National Physical Laboratory lab in New Delhi. So the prototype of mass is available in India at NPL, National Physical Laboratory, or lab you can say that, which is situated in New Delhi. Right. Now the SI unit of mass is kilogram. We have already discussed this in our SI unit system video lecture, right? In a video lecture where we have discussed about SI unit system. So the unit of mass is kilogram. Remember, kilo is a prefix like milligram, mega, right? Micro. So these are all prefix. So kilo is also a prefix, which means 10 raised to 3. So remaining units are having no prefix, right? Rest of the units are without prefix, but kilogram, this mass has a unit with some prefix. Gram and kilogram. Kilo means 10 raised to 3. We are not writing kilometer as our SI unit for measurement of length. We are just writing its meter, right? Kilo ampere, something like that we are not writing, right? But here in gram, instead of gram, we have taken kilogram as our SI unit system. So why kilogram? For that, let us study a little bit of history related to mass. Initially, the unit of mass was given as grave. Initially, the unit of mass was decided as grave. Now, what is grave? The mass of, you can say that the mass of water which is at 0 degrees Celsius, the mass of water at 0 degrees Celsius having volume 1 centimeter cube. The mass of water at 0 degrees Celsius having volume 1 centimeter cube is defined as 1 grave. Now having volume 1 centimeter cube means what? Suppose if we take a cube, let us say we have a cube of side 1 centimeter. So this will be 1 centimeter. This is also 1 centimeter. While this is also 1 centimeter. So if we take a cube of side 1 centimeter, then its volume will be 1 centimeter cube. Now if in this cube we will fill water, right? Then that mass of that quantity of water which is at 0 degrees Celsius was defined as 1 grave. Why 0 degrees Celsius? Because at that time for us it was quite easy to attain 0 degrees Celsius as well as to maintain 0 degrees Celsius. So mass was defined as 1 grave, right? Unit was defined as 1 grave, which is the mass of water at 0 degrees Celsius having volume 1 centimeter cube. Now later on this grave was converted into gram. So the mass of water at 0 degrees Celsius having volume 1 centimeter cube is known as 1 gram. But here instead of 0 degrees Celsius, we have now taken it as 4 degrees Celsius. So the definition for gram was the mass of water at 4 degrees Celsius having volume 1 centimeter cube. Now why 4 degrees Celsius and not 0 degrees Celsius? The reason is quite simple. The density of water at 4 degrees Celsius is maximum, and that is 1 gram per centimeter cube. Right? So the density of water is maximum at 4 degrees Celsius. If you increase temperature beyond 4 degrees Celsius or if you lower the temperature below 4 degrees Celsius, then the density of water will decrease. And this maximum at 4 degrees Celsius, and that's why we have taken here 4 degrees Celsius. So the mass of water at 4 degrees Celsius having volume 1 centimeter cube is known as 1 gram. Clear? Now, In day-to-day life, 1 gram, unit of gram, that is unit of mass, 1 gram was quite small. Suppose if you go to a grocery shop and you want to buy something, then what you will measure in terms of gram? Right? Few pieces of grapes, right, will be measured in terms of gram. Few almonds will be in terms of gram. But most of our things were having mass quite greater than gram. So it was found that instead of gram, the practical use of weights which we are using, or practical mass which we are dealing with, was something around 1000 grams, right? Suppose if you go to any grocery shop or somewhere else in the market and you will not buy 2 gram, 3 gram, 10 gram, 100 gram, right? Generally, most of the cases, we buy something around 1 kg, that is 1000 gram, 2000 gram, 5000 gram, right? So it was found that instead of gram, 1000 gram is quite useful for us in day-to-day life, right? Instead of gram, in day-to-day life, we use 1000 grams quite often, and that's why the unit of mass was defined as 1000 gram. So we have defined unit as 1000 gram, and this 1000 means kilo, which you are already knowing. So the unit of mass was defined as kilogram, right? And that's why we are having an SI unit of mass as kilogram. Clear? Now 1 kilogram was defined. 1 kilogram is equal to the mass of international prototype of a kilogram, that is IPK, of platinum, which is made up of a platinum iridium alloy in the form of cylinder, and it is kept at International Bureau of Weight and Measurement at Sèvres near Paris in France, right? So what is 1 kilogram? 1 kilogram was defined as the mass of international prototype of the kilogram that is IPK, which is made up of platinum iridium alloy in the form of cylinder, so the mass of that international prototype of kilogram was considered as 1 kg, 1 kilogram. It is kept at International Bureau of Weights and Measurement, right? So it is kept at, you can say that it is kept at International Bureau of Weight and Measurement. It is kept at International Bureau of Weight and Measurement at Sèvres near Paris in France. So the International Bureau of Weight and Measurement at Sèvres, kept in near Paris, right? It is kept in Sèvres near Paris in France, right? So that prototype, which is made in the form of cylinder, so we have a cylindrical alloy. Made up of platinum iridium, right? And it is kept at Sèvres near Paris in France. And it was defined that the mass of this cylinder is 1 kilogram. So we have defined 1 kilogram as a mass of some alloy, right, which is made up of platinum iridium. Now here we have some problem, right? the time when IPK was defined till date, the mass of this cylinder has decreased by 50 microgram. So the time when IPK was defined, the time when IPK was defined till date, the mass of that cylinder has been decreased by 50 microgram. So after say few years, let us say hundreds of years, the mass will decrease by 200 gram. Then also we will say that the mass of that cylinder is 1 kilogram only. So it was necessary to redefine 1 kilogram, right? Because we have defined something related to some variable quantity. Now to define something related to some variable quantity is not good because it will keep on changing. But the definition of some object, something, some unit should always remain constant. But here we have some cylinder, right, which is changing with time. Its mass is changing with time, and hence kilogram can't be defined on the basis of this cylinder. So it was necessary to redefine mass. All the committee members of IPK agreed to redefine it to a certain quantity on 16 November 2018, and it has came into force, right? We have implemented it in May 2019, right? So from May 2019, the unit of mass has been redefined, and we have another definition of 1 kilogram. We are not going to go in detail with that. What we have done, with the help of this mass, right? With the help of this mass, we have defined a Planck constant, which will come across in 11th standard only in chemistry. Planck constant, what is Planck constant and all that you will come across, right? So Planck constant was defined with the help of 1 kilogram, and that value was locked. The value of Planck constant H. So the value of Planck constant was calculated as 6.626070015 into 10 to the power minus 34 kg meter square per second. Right, kg meter square per second. This was the value of Planck constant which was calculated, and it was locked. Locked means the value of Planck constant was now considered as universal constant. It will not change, right? Like gravitational constant, capital G, universal constant of gravitation or gravitational universal constant, capital G. Its value is fixed, right? So in the same way, here H, Planck constant was the value of Planck constant was fixed, and with the help of this Planck constant, we have defined the new unit of mass. Right, so the new unit of mass was defined on the basis of Planck constant. Remember here Planck constant, the value of Planck constant was obtained by using this mass only. And from that mass we have defined, from that Planck constant we have defined mass. So from mass we have obtained Planck constant, and from again that Planck constant we have defined mass. It is similar to how we got meter from the speed of light and speed of light to meter. Right, so this is how we got new definition of mass. It was forced on, you can say 20 May 2019. I think it is 20 May 2019 the new definition of mass was introduced. But still it is not in our syllabus, and we are not going to discuss that in that detail. Okay. Now, the unit 1 kg of mass is not always appropriate. In most of the cases, 1 kg is quite suitable for us. On the other hand, while we are measuring the mass of some heavy object like mass of a loaded truck, mass of a good containers, right? So in that case, the mass will be measured in terms of tons, right? In the same way, mass is kilogram is a very big unit. Kilogram is a very big unit when we are dealing with atomic and subatomic, that is nuclear physics. So when we discuss about atomic physics or nuclear physics, we will find that mass of electrons and proton is very less compared to 1 kg, right? So in that case, we have defined a new unit of mass which is known as atomic unit of mass, AMU, atomic mass unit you can say. So what is one atomic mass unit? 1 AMU, which is also written as 1 U. So what is 1 AMU or 1 U? The mass of 12th part of an unexcited carbon atom. The mass mass of 12th part of an unexcited carbon atom is known as 1U, 1 atomic mass unit. And its value is, you can say that 1U is 1.66 into 10 to the power minus 27 kg. This is the value of 1U. Why we have to define 1U? Because the mass of electron is 9.11 into 10 to the power minus 31 kg. So always if we want to write mass of electron in atomic and subatomic physics, then we will always write 9.11 into 10 to the power minus 31 kg. In the same way, mass of proton is 1.67 into 10 to the power minus 27 kg. So always we have to deal with this 10 raised to minus 31, 10 raised to minus 27, and instead of that we have defined a smaller unit, that is 1U, which is 1.66 into 10 to the power minus 27 kg. You can say that this is nearly equal to mass of proton. So you can say that mass of proton is 1U, nearly, right? Because mass of proton is 1.67 into 10 to the power minus 27 kg. So for atomic and subatomic physics, we have new definition of mass, right? Which is 1 atomic mass unit. For atomic and nuclear physics, we have defined many different units, right? Instead of energy in terms of joule, we are using unit of energy as EV, electron volt, right? Which you will come across in standard 12. So atomic and subatomic physics has new definitions for mass, energy and many other physical quantities.